Hello friends, welcome back to the class of thermodynamics. In today's class, we will see about the how to solve the problems based on the PDV work. PDV work means pressure volume work. In our previous session, we have seen how to find or what is the formula to find the PDV work for different processes. In today's session, we will see the problems based on the PDV work and how to solve them. Okay, now take this example, first problem. It is written an engine cylinder has a piston of area 0.12 meter cube, okay, and contains gas at a pressure of this much. The gas expands according to the process which is represented by a straight line on a pressure volume diagram. How the process is represented as a straight line in pressure volume diagram. The final pressure is this zero point 0.5 no 0.15 megapascal. Okay, now you have to calculate the work done by the gas on the piston if stroke is 0.3 meter. So this is the problem statement. How to proceed? So we have to draw the PV diagram for it. So this is the PV diagram, means pressure volume diagram. Okay, now as you can see here, initially the pressure was 1.5 megapascal. So this is the initial point. Pressure is 1.5 megapascal. Okay, the next, the final pressure is 0.15 megapascal. Okay, so this is the next case where the pressure is 0.15 megapascal. Okay, now volume, what about volume? So here area is given 0.12 meter square. This meter is square. So area is given 0.12 meter square, and the stroke of piston means length, how much distance a piston is moving. uh, I will explain you what is our system. This is a cylinder. Okay, inside this cylinder there is a piston. Okay, this is our piston. Here gas is there. Okay, gas is there here. This is piston, this is cylinder, this is gas. Okay, now here written stroke. What do you understand by stroke? Suppose this is the initial position of piston and piston moves up to this point. Piston moves up to new point, which is this. So this distance, this distance is known as stroke, which is 0.3 meter. Okay, so this is our system. Now initial pressure is given how much? 1.5 megapascal. Final 0.15 megapascal. Okay. Now volume, initial volume is, area is given 0.12 meter square and stroke is 0.3. So length into area will give you volume. So you get the initial volume or final volume. This is a stroke. Stroke comes when the piston travels some distance. How you will get the stroke? When the piston travels some distance. So this is the area of piston. It will be always same. Area of piston will be always same. Okay. And the stroke table means final distance, final position, that is 0.3 meter. Okay. So final volume will be how much? This much, 0.3 into 0.12. Okay. Now first pressure and second pressure, it is very much in comparison to this. Okay, so we are neglecting the volume. So we are neglecting the volume. Why we are neglecting volume? Because this pressure is very much high compared to this. So we are neglecting the volume. Okay. Now what is the formula? Formula, how much pressure into volume. But you are given two pressure. You are given two pressure. So you take, and this is varying in a straight line. This is varying in a straight line. So you take the average of this, you will get the pressure into volume. Here it is written, the pressure is varying in a straight line. It is varying constantly in a straight line, okay? So what will be your pressure? It will be average of initial and final. It will be average of initial and final, okay? So pressure into volume. Average of initial and final into volume. Put the values, you will get the work done. It is how much? 29.7 kilojoule. So this is one of the kind of problem in the case of PDV work. This kind of problem can be asked in case of PDV work. Okay. Here initial pressure, final pressure is given, area of piston is given which will be constant, stroke means distance is given. So distance into area will give you volume, okay, and work done will be PdV, V is given this much and pressure, two pressures are given. So you take average of it. So by this method you can find the work done. In the case of piston cylinder arrangement, okay. Next case, suppose determine the work done by a gas system. Given system is gas following an expansion process as shown in figure. Okay, this is given. This figure is given in the question. You have to find the work done for this case. Now here what is the thing? Process AB, then process BC. Process AB is straight line. Process BC follows this equation P into V power 1.3 equals to C. We have seen polytropic process. In polytropic process, you know the relationship P into V to the power N equals to constant. This is polytropic process. Here in place of N, the value of N is given 1.3. Okay. So process BC follow this law or this equation. Process AB, here this is straight line, means pressure is constant. How much? It is given here 50. Given here 50. Now at point A, volume is given how much? 0.2 meter cube. Point B, volume is zero point 0.4 meter cube, and point C, volume is zero point 0.8 meter cube. So you have to find work done. So first of all, what you will do? First of all, you will find the work done for process AB. Then you will find work done for process BC. Then you add. Then you add both. You will get the total work done. First, you have to find the work done for process AB. Then you have to find the work done for process BC. Then you add both. You will get the total work done. Now, how is you will get the work done? Suppose first of all you will take process AB. Process AB is constant pressure. Constant pressure. For constant pressure, work done is given by W equals to P into dV. P into dV. dV is nothing but final minus initial. Final minus initial. For process AB, final volume is, for process AB, final volume will be how much? Yes, zero point 0.4. Zero point 0.4. Okay. So 0.4 and initial will be 0.2. So 0.4 minus 0.2. Okay. Let us see. Let us check. See here. Final volume minus initial volume, zero point 0.4 minus 0.2 into pressure 50 bar. 50 bar. If I will convert into Pascal, it will be 15 to 10 to the power 5. 15 to 10 to the power 5. Okay. Write down the values. You will get the work done for process AB. It is coming how much? 1 megajoule. Okay. Now next, process BC. Okay, for process BC, work done will be how much? What is the work done? Yes, write in the comment box. Write in the comment. This is polytropic process. So work done will be how much? P1 V1 minus P2 V2 divided by n minus 1. This is the work done for polytropic process. Here value of n is given 1.3. Okay, correct? Now how to proceed? How to proceed? Why? P1 will be given to you. V1 is given. V2 is given. What about P2? What about P2? Okay. So how we will proceed? Just see the process. PB is given 50 bar. Okay. Now you are given this process. So you can write P1 V1 power 1.3 equals to P2 V2 power 1.3. Same thing here. Same thing. PC, you don't know pressure at point C. So PC we will get by PV into VV power 1.3 divided by VC power 1.3. From here we will get the value of PC. It is coming this much Pascal. Okay. Now work done as I told you already told you formula this much. So put the values of pressure and volume at point B, pressure and volume at point C, value of N as 1.3. You will get this much work done. We'll get this much work done for process BC. Okay. Now this is work done for process AB. This is for process BC. So total work done will be add both. Add both. Okay. We'll get total work done which will be 1 plus 1.25. This is equal to 2.25 mega joule or mega joule. Okay. This is the model. Second model, how you will solve the problem. Thank you friends. I hope it is clear how to you can now calculate how work done can be calculated for the different kind of processes. Okay. So we will meet you in the next session of thermodynamics. Till then, goodbye.